All right. Moving on to the back. We have letter C, fluorine gas reacting with aqueous sodium chloride. This is non-metal replacement. So we know that fluorine gas is a non-metal, hopefully by reading the word gas. But anytime we have non-metal replacement, the non-metal by itself is a genuine diatomic element. So that means that fluorine gas is F2. And it's a gas, so it gets a symbol parentheses G. Now, aqueous sodium chloride, we do need to work out the charges. Sodium is Na with a +1 charge. Chloride is Cl with a -1 charge. So aqueous sodium chloride is NaCl. It's aqueous. Now, you're never going to figure it out if you compare F2 to Na, because that's not comparing apples to apples. F2 is a gas, the non-metal. It will replace the non-metal in the compound. And if you remember how we write ionic compounds, it's always the non-metal second. So you have to make sure you're comparing the right things to each other. You're comparing F2 to Cl. In this on your blue sheet is the little tiny chart on the right side of your blue sheet. So you'll find that F2 is in fact higher on the activity series of non-metals than Cl. So we're going to displace Cl. Now non-metals are genuines. They are diatomic. So when you replace a non-metal, it's going to have subscript of 2. So it's going to be Cl2, and it's a gas. I told you that when I introduced the blue sheet. And then we're going to have Na with that. Now, remember how we write ionic compounds. It's not going to be F and N. We always write the cation first, and in the case of non-metal replacements, the cation is going to be written first. So with non-metal replacements, the non-metal is, some students write the non-metal first. It's not the case. You always write the metal first. So you have to work out your charges, Na +1. Now, it's not going to be NaF2 because we don't care about what subscripts were. We care about how charges balance. So it's not NaF2 because the charge of the Na is a +1. And the fluoride ion is -1. So this sodium fluoride is just going to be NaF. It's going to be aqueous because it's a compound and single replacement reaction. Balancing this is pretty simple. We need 2 NaCls. And 2 NaFs. Now the complete ionic equation. Gases work identically as solids. Solids, liquids, and gases are going to keep exactly the same. So I want you to circle the gases because those stay exactly the same. So we get fluorine gas, F2 gas. That's going to stay exactly the same. Again, gases and liquids work identically to solids. You just keep it exactly the same and neutral. The only difference between non-metal replacement and metal replacement is the nonmetals are diatomic. So it's going to be F2 gas. We come to something aqueous, so we're going to split it apart. So the 2Na plus 1 aqueous. Now that 2 distributes to the Cl as well. So we have 2 Cl -1 ions aqueous. Now we come to something we circled, so we blindly copied the gas down. So Cl2 gas. And then we get to something aqueous, so we're going to split it apart. 2Na plus 1 aqueous. Plus the 2 also distributes to the F, so 2F minus 1 aqueous. Now you do have to change gears a little bit and ask yourself, okay, in non-metal replacement, what are my spectator ions? Now I'll give you a hint, in non-metal replacement, it's going to be the cation that are your spectator ions that you're going to cancel out. So your cation is what cancels out in non-metal replacement. So 2Na plus 1 aqueous, 2Na plus 1 aqueous. Everything about the spectator ion needs to be the same. So the only thing that cancels out is the 2Na plus 1. Now, something I do want to mention, it's going to be most helpful to circle your gases or liquids or solids, especially gases and liquids in non-metal replacement, because gases stay the same. We don't kick out the subscript and make it a coefficient. If it's a gas, we keep it diatomic. So then the net ionic equation then is F2 gas plus 2 Cl -1 ions aqueous, yielding Cl2 gas plus 2 F minus 1 ions aqueous. Now don't get confused with non-metal replacement. Reduce and oxidize mean the same thing in non-metal replacement as it does in metal replacement. Okay? So reduce still means goes down. Now, unlike metal replacement, where reduce means we go from a cation to a neutral atom, and oxidize means we go from a neutral atom to a cation. Non-metals, you do have to think about the number line. Okay, -0 to -1 goes down. So reduced in non-metal replacement means you go from 0 neutral charge to a -1. Okay. Oxidize means goes up in non-metal replacement. Oxidize goes from a -1 to 0. So let's flesh that out up here. Reduced means goes down. And again, we go from neutral to -1 for non-metal reduction. So the F2 was neutral, 0 charge, and it went to 2F minus 1. So 0 to -1 was in fact reduced. Now the Cl -1 must have been oxidized. We go from -1 to 0, so that goes up. So that was oxidized. I still love doing the oxidation half reaction first. Again, oxidation reduction works exactly the same in non-metal replacement. You still in oxidation have electrons being added to the products. The only difference with non-metal replacement, oxidation, and reduction half reactions is that you're trying to get both sides of the chemical equation, half reaction, to be negative, typically -2. So we have the oxidation half reaction, 2 Cl -1 aqueous ions, yielding Cl2 gas. Now this reactant side of the oxidation half reaction is -2, right? Because 2 times -1. Now again, we don't take away electrons, we don't make electrons have a positive charge. We just simply, in oxidation, add electrons to the right side of the equation, the products. So we have -2 for our net charge and the reactants of the oxidation half reaction. We need to make the products a -2. So we need 2 electrons with our chlorine gas in the products. So that'll be -2, yielding 0 plus -2, which will be -2. The reduction half reaction is then going to be the fluorine gas. Blindly react that with your 2 electrons. And that's going to yield your 2 fluoride -1 ions aqueous. Now check that out. We've got F2, so that's a 0, it's neutral, plus 2 -1 charges, so 4 -2, and that's going to yield 2 -1 ions, so that's a -2, -2, 0 plus -2 is -2, so -2 yields -2. And again, yeah, non-metal replacement works identically to non-metal metal replacement, except that non-metals are going to replace non-metals. Oxidation and reduction still means the same thing in non-metal replacement. The only thing you do have to think about the number line. Okay, 0 to -1 means it's reduced. -1 to 0 means it's oxidized.